rule is that magnetic fields actually go around wires. And the effect is very small. The magnetic field generated is multiplied by a very small number. Okay? But what I have here is I've got like 30 wires. I've wrapped this thing around 30 times. So if I put 1 amp through this whole coil and I hook it up right, we'll actually have 30 amps there. And if I put like 5 amps, which I think it can sustain 5 amps and just get barely warm, then we've actually got like 150 amps, right, of current going around that. And these stands are aluminum, so we shouldn't have any magnetic interference. So I think I hooked the negative to this guy to make it go the direction that it says. And I hooked the positive to this side. Let's make sure we got, okay. And then I'm going to turn this on. And wow, that's a lot of current. Okay. I'm going to put it at 6 amps. It'll get a little bit warm here. Okay. So right now there's 6 times 30, 180 amps of current going around. And this is why they put lots of windings in magnets, et cetera, et cetera. Every winding just makes the current, that much more current on there, right? Go through there. So that's why motors have a lot of windings, et cetera, et cetera. Yeah, it's starting to get a little bit warm. Okay. Now, the magnetic field around this thing, here's the rule, is you stick your thumb in the direction of the current and you wrap your fingers, this has to be your right hand, your fingers wrap in the direction of the magnetic field. Okay? So our first rule is this, is the wire rule. Okay? Is thumb in the direction of the current, right? Your fingers wrap as the magnetic field. Yeah? The fingers will wrap as the magnetic field. So that means there should be a magnetic field going around this wire, which is somewhat surprising, right? Let's see if this thing can respond to it. Well, so far so good. Okay, yeah, and this is very cool, right? Remember that a compass needle, this is like a giant compass needle. Compass needles point in the direction of the magnetic field. The North Pole points the way, right, of the magnetic field, right? So watch this. It's like, we'll put it here. In front it should be to the side and it's not moving. And around this side it should be backwards. Hello. Yeah. On this side it should go this way. Which little, oh, the little magnet probe. I know, yeah, you guys can see the magnet probe, right? Okay. Yeah, the magnet probe works real slick for this, right? Just nobody back there can see it, right? So, yeah, this thing is pointing like a little dog around the wire exactly the way my fingers say, right? So that's our first rule, is that it makes little circles, right? And then the thing you don't know is that this drops off as 1 over r. It's a 1 over r thing here, so if you double the distance, you get half the magnetic field. And we don't learn that anymore. That's Ampere's law. Okay? So this is our first rule. Let's practice this rule. I'm going to turn this off so it doesn't get too warm. Okay? So here's this wire, right? Get your right hand out. Everybody pull out their right hand. Make sure it is the right hand. Now, if you're right-left impaired, and I've had kids that have trouble with this because they can't tell their right from their left. Okay? You could, it's not cheating to write an R on your right hand. Okay? My mom, honestly, God, my mom, I tell her now, turn right, and she's like, she does something like L that makes an L. Is that right? Yeah. 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 She checks. I know. It's like this is an L too, right? You know? Okay. I'm reminded of, this is exciting. I'm reminded of Winnie the Pooh, right? Where they're trying to get, I think it's the part where they're trying to get Roo lost or something to teach him a lesson or something, right? But Roo doesn't get lost, everybody else gets lost, right? And I think it's, somebody says to Pooh, I think it's more to the right, and Pooh looks at his hands. Pooh looked at both of his hands. He knew that one of them was the right hand, and he knew that once you decided which one was the right, that the other one was the left, but he could just never remember where to begin. It's like that. But anyway, we've got our right hand, we have our right hand. Okay, now pretend that you are grabbing that wire. Are you grabbing that wire? Is your thumb pointing up? Yes. Your fingers are going into the page on the right side of the wire. On behind the wire, they're going to the left. To the left side of the wire, they're coming out of the page, aren't they? So pretend your fingers are little arrows. Yeah? And in front of the wire, which way are your fingers pointed? To the right, correct? Yeah? The magnetic field is to the right, and that's just what we figured out here. Okay? The magnetic field here is actually that way. Okay? How about behind the wire? Which way?
To the left.
It's to the left, right? We've got our current is like this. We wrap our fingers around it, and behind the wire, my fingers are pointing to the left, like little arrows. Yeah? Are we good? How about behind that wire? Thumb in the direction of the current. Which way is it? It's up the page, yes? On this page, it is up that page, yes? Okay? Okay, a magnetic field around this wire. Well, let's see. Put our thumbs down. How would we do that? How would we say around that wire? I guess we'd have to say from above, which way is it? It's clockwise from above, yes? It is clockwise as seen from above. Yeah? All right, now, second thing. Here's the second thing. A loop of wire, therefore, acts like a magnetic field. So let's turn this thing back on. Now, this is a loop of wire. Okay? Loops of wire act like magnets. They act like little magnets. In fact, all magnetism comes from current going in one direction or another direction. Okay? Now, here's how we do it. Okay? If you think of a North Pole magnet, let's draw a picture of a North Pole magnet and a South Pole. Here's the North Pole, here's the South Pole. The magnetic field lines issue from the North Pole and go to the South Pole. Yeah? So by reverse logic, if we have a pole from which magnetic field lines issue, it must be a North Pole. And if the magnetic field lines go into it, it must be a South Pole. Yeah? This is important. Yeah? We can recognize any pole immediately. If the lines come out of it, it's a North Pole. Same thing was true for charge, right? If the field lines go away from the charge, it must be positive. Toward it, it must be negative. Okay? But now we're talking about magnetism here. Now, think about this loop. On this side, the magnetic field is this way. Notice that inside the loop, and we're always talking about inside the loop, aren't the magnetic field lines coming toward you? And if I do it up here, the magnetic field wraps around the loop. Isn't it toward you? The magnetic field is coming toward you inside the loop. And here, okay, the magnetic field lines wrap around this way. Inside, it's toward you all around, and it's all coming toward you, yes? Okay, that means that this side is actually, and here's the rule, you wrap your fingers as the current goes, your thumb is the North Pole. Okay? So the second rule is for a loop. So loop currents. The loop rule is put your fingers as the current, right? Your thumb is the North Pole. Right? So if you wondered where the North Pole is, why there it is, you know? Okay? Santa's workshop is, really close, right? Okay, so what that's saying is that if we wrap our fingers this way, this should be a North Pole. This thing, which pole of this should like it? South Pole. Let's see if that's true. Well, let's turn it around. Oh, indeed, look at that. The South Pole side, right, the end of the arrow is liking this side here, right? And I can turn it around and it definitely does not, right? The South Pole likes this side, so therefore it must be a North Pole, right? So two ways to predict it. One, we can just measure it, right? Indeed, this is a South Pole on this side of the magnet, right? The other way is to wrap our fingers around, and your thumb is the North Pole. Okay? So this is the second rule, and this is, vitally important rule, a bedrock thing that we have to learn. So let's practice this a little bit. Yay. All right, so where's the North Pole on this one?
This way.
Yeah, this North Pole is coming at you, right? Ta-da, wrap your fingers around. The North Pole is away from you. The butt of your fist, if you're using your right hand, is the South Pole. South Pole is away from you, North Pole is toward you. Yeah? You guys are like trying to look around the thing. Okay? All right, are we ready for the next one? So now we're wrapping our fingers as the current goes. Yeah, he's here. Well, now it's the other way, right? So now the North Pole is into the page. The pole facing us is the South Pole, right? This is going to act like a little ceramic magnet, just like those magnets, right? This side will act like the South Pole facing us. It will attract north poles, repel